For our next presentation, Balazas, it's correct? Belesh, sorry. Belesh. No, sorry. I will call you for Andres, is correct? No, sorry, I will call you Andres. From University of South Denmark, with the paper Standard Energy Data Competition Procedure, a comprehensive review with a case study of adrenaline load disaggregation competition. So, Andres, this is the best microphone.
So, I'm going to present my review of data science competition hosting. So, the crowdsourcing of data science problems have gained increasing popularity over the past decade. Crowdsourcing is a cost-effective alternative to traditional hiring, which can result in a bigger group of diverse and innovative solutions. Participants outside of an opportunity to earn some prize money also get to learn, and as these competitions have become quite a high reputation, it's actually a really nice addition to one's professional portfolio. To conduct my review, I analyzed 33 competitions that I collected last year with a focus on the competitions included in Neural IPS's workshop. We have identified 7 elements of competition hosting, which I'm going to introduce in detail. Official websites, their main purpose is to share information with the competitors. This can be done by a known website, which can be supplemented by Git, or by using one of the hosting platforms. These hosting platforms are websites that were specifically designed to host these competitions. These have some distinct features, such as the handling and the evaluation of submissions, and also maintaining a live leaderboard. It is not necessary to use one of these platforms, but it can make the hosting process a lot easier. To get a better understanding of what platforms are available, we analyzed 12 platforms using 16 criteria, which include the availability of different features and other things like ease of participation and active community. Based on this evaluation, the top 4 platforms were Kaggle, closely followed by AI Crowd, EI.A, and Codalab. But there are multiple options to consider, such as there are open source platforms, which means these are not only completely free to use, but one could also create their own instances if they wish to do so. These are EI and Codalab. There are also regional competition platforms, such as Zindi, which is focusing on the African data science community, and Yankee, which mainly hosts Chinese competitions. Competition descriptions are the information shared on the official website. This includes the background information, which describes why the problem we are trying to solve is important, and also the formulation of said problem. It also includes other more important information, such as timelines, prizes, dataset descriptions, submissions, and also the process of the dataset evaluation and the set of rules. Some competitions have a phase before the main event begins, which is what we call pre-phases. This main reason is to give an opportunity for the competitors to familiarize themselves with the problem and the dataset, but this also gives an opportunity for the hosts to make some adjustments to the competition based on feedback. The main phase is usually the development phase, which is when the competitors are expected to develop their models and test them against the public leaderboard. This can be fractured to separate phases by releasing the data in different portions. And this is often followed by a private evaluation round where the final score is calculated on a previously unseen data set. The main phases can also include topic-specific phases or multiple tracks, which are phases that are running parallel to each other. Competitions have varying durations, but our review showed that most competitions have around 3 months for the main stage. The second stage is usually shorter, especially if this is a private evaluation round, which is usually very short, around 6 days. Starter kits are a downloadable package which includes a working submission. This is especially important for reinforcement learning and code submission competitions, because these competitions will have different requirements for the submissions format to be able to ingest it and run by the host side. Datasets are, of course, one of the most important parts of a data science competition, as without sufficient amount of data, it is not possible to properly learn. Submissions have 2 main types. Result submissions, when the participants are expected to calculate their predictions locally and submit these predictions, or code submission, where previously trained models or codes are submitted and these are run on the host side. Of course, this has the advantage of not having to disclose any of the test data. Evaluation is the process of automatically calculating the score for the submissions. The final score is usually calculated by either a private leaderboard or a private test phase, which is necessary to combat leaderboard probing. The scores are calculated by a metric, which are different mathematical formulae to calculate the score. Some of them are well known, such as F1 score. But the selection of these metrics is very important, because these will be the target of the participants' optimization. So if we pick one that is not relevant for our problem, then the submissions are not going to be relevant either. And I'm going to quickly introduce the case study, which is the ADRENALIN Building Energy Load Disaggregation Challenge, which we designed based on the previous review. We made a scoping review to further lower the scope of our research. And we identified that we are going to focus on lightweight models and transferability. Our challenge will have a website, and we will use the platform Codolab. We will have 3 stages: a warm-up stage, a development phase, and a private test phase. Our data set will be a diverse data set made up of multiple buildings across the globe, provided by our project partners. And we will also allow the usage of external data. We will use result submission and Codolab submission system to handle the submissions. And the metrics we choose through further analysis of metrics used in energy disaggregation are mean absolute error, complemented by relative mean absolute error and mean absolute percentage error. Thank you.
Thank you. Some question from the audience? No one? I just would like, please.
Yes, so maybe I have a question. First of all, I would like to compliment is on the conference webpage, actually you can see the adrenaline competition information. We are going to update it and would like to invite all of you who's interested first. The second one is I would like to have a question regarding this evaluation metrics. And can you elaborate what evaluation metrics have been used in the existing data computation and why we choose this, and if there's any kinds of like disadvantage by using these metrics?
Well, there is really a very large amount of metrics that have been used in competitions. It mainly depends on what kind of competition it is. So we choose these because these were the ones that were mainly used by other energy load disaggregation papers. The disadvantages are that if you calculate maybe a global mean absolute error, then it might mask smaller timelines of big mistakes.
Maybe I have a follow-up question. It's also because of we also have one is energy load review paper. So for the energy load, as the review paper results is very much rather based on this regarding heating, and in that way actually is how. So it means based on seasonal difference, how well you are going to dealing with this problem to evaluate the models, the accuracy.
Well, I'm not sure if it's a problem because there are basically the times when we have heating and when we don't have heating. And when we don't have heating, the accuracy is expected to be relatively good. And so it will kind of have the same difference for everyone.
Sorry about that. I think maybe can you explain about what the data set is going to be provided and used?
Yes, we'll have different buildings in which we have submetered different appliances, mainly the weather-dependent appliances, heating and cooling. These buildings are very varying, mainly office buildings and schools and other buildings. And these are across the globe. We have buildings from Germany, Denmark, and we even have buildings from Australia.